Okay, so welcome. My name's Kabir Khan. I'm a core developer on WildFly. I've been with the project since its beginning in 2010. And today we're going to talk about what's new in WildFly 9. So I couldn't fit the long title into my slides, but it's about the clustering improvements and server management improvements. And we'll have a look at what's coming up in WildFly 9, in WildFly 10, which is the next release. So WildFly basically is Red Hat's open source application server. So it's a community project with frequent releases and rapid innovation. And it's really fast. I don't know if any of you use WildFly, but we'll see in the demos that it starts up in a matter of seconds. This is achieved via our modular class loading framework, which reduces class loading time needed to look up a class when you want to load a class. And it also has a concurrent service container, which installs all the services that we use in the server, so they can all be installed in parallel. It's Java EE7 compliant, although that's old news. We supported this already in WildFly 8, which came out in February last year. And it's the upstream for JBoss AOP, which is our supported offering, which is what our big customers buy. So we currently have WildFly 9 CR2, so final should be coming out in a few weeks. So we'll have a look at what's new. So we'll have a look at some enhancements brought in by Undertow, which is the new web server in WildFly. So we'll have a look at how we support HTTP2 now, and we also support the use of WildFly itself as a front end to mod cluster for using load balancing. We'll have a look at some of the improvements in server management. So, for example, our offline CLI. So we'll have a few demos about all these things. We won't be going that much into depth into everything, but we will. So I'll basically skim through, and I'll have some demos showing stuff, and they're all available on my GitHub if you can't, or if I'm going too fast in this presentation. And WildFly is available on OpenShift, which is Red Hat's platform as a service. So the CR2 cartridge is already up there. So the final one will come once the final release is out. So Undertow is the web server that we introduced in WildFly 8. So it's really fast, like all the other WildFly projects. So it supports blocking and non-blocking APIs over NIO. It supports Servlet 3.1, and it has built-in upgrade in its core. So we use this to reduce ports, so that all our management APIs, EJB remoting, messaging, and so on, are all available via HTTP, and then an upgrade is done to talk these other protocols. So the things that Undertow brings in new in WildFly 9 are the ability to use WildFly itself as a front-end load balancer. And it also brings in HTTP2 support. So our load balancer is basically based on mod cluster, which is a HTTPD-based load balancer. No static configuration is needed, so basically the load balancer will send out some advertising messages via IP multicast. The servers are listening for this multicast, pick up this message, and connect back into the load balancer. So basically no prior configuration is needed apart from agreeing on the multicast address and the multicast port. Then when running, mod clusters built so that the back-end servers basically feed information back to the front-end load balancer. which then makes informed decisions about where to route the next request, because it's got the live information about what's going on in the cluster. It's also got fine-grained application control, lifecycle control, so that if you undeploy an application from one of the backend servers, mod cluster will inform the load balancer of this, and this will effectively then get taken out from the set of backend servers to handle a particular application. So previously with mod cluster, we've had to put Apache or something like that in front and to mess around with httpd conf. However, in WildFly, WildFly now can itself be used as the front-end mod cluster. And this means that we can manage the whole thing with our management APIs. So it's the same configuration for everything within the load balancer and backend servers. So now I'm going to show you a little demo about how to set up mod cluster for use as a load balancer using WildFly. Okay, so I'd already started it. So the first thing I need to do is to start JBoss bound to a real IP address. This is because IP multicast does not work over localhost, so I'm passing in my local address. I'm actually starting domain mode, so rather than having lots of standalone instances, I'm having a domain mode on which I will set up one front-end server and two back-end servers, so they can all be managed via in the same domain. But if you're doing this in production or something, you'd probably have a domain spanning multiple hosts, but in this case, everything's running on this one laptop. So the first thing I'm going to do is to basically clean out everything that's in the default configuration. So I'm basically stopping all the servers, removing all the servers, and all the server groups that are there. So now we have a clean domain without anything in it, or at least no servers. Then the next thing is in the high availability profile. So this is a profile set up for clustering. I set that the default host is this IP address that I specified. So this is so that the mod cluster front end eventually will associate itself with this backend server for requests coming to this address. And then I'll set some key for use with mod clusters so that the backend servers authenticate when registering with the load balancer. So now I'm going to add some new servers. So I create a server group called backend servers. And then I add a backend 1 and a backend 2 server. And then I'll start all the servers. You'll notice that I'm using a different port offset for both the servers. That's because the normal HTTP port on which WildFly listens is 8080. And this is the one that the load balancer will use once we add this. But then the two backend servers will be accessible on 8180 and 8280. So it's a demo, so something went wrong. I'll start as a standalone instance rather than domain instance. So I'll just run those 3 scripts again, and now we should be back in business. So now the backend servers should be added fine. So that completed successfully. So we see those starting up here. So we've got the backend 2 server. The backend 1 server started further up. So now we're going to deploy a little application just to show off the load balancing functionality. So we have a little servlet, which basically just prints out the name of the server that the request is executing on. And then if you pass in the stateful parameter, then this will initiate a session, keep track of the request count, and store that in the session. The 2 backend servers will form a cluster because they're using the HA profile. And this distributable flag in the web XML basically will replicate the state between the 2 servers that's put in the session. So now we deploy the application to the backend servers. So we see that's picked up. So if you go to the first server, we see backend 1. If you go to the other server, then unsurprisingly, we see... Yeah, it should be 8280. So on 8180, we have backend 1. On 8280, we have backend 2. So now I'm going to set up the load balancer. So we execute some CLI commands for this. We're basically saying this now belongs to another profile on the HA profile. So we're setting up a new socket binding to advertise the message that the load balancer sends out to inform the backend servers that this is where the load balancer is. Then in the default profile, we set up some filters for the Undertow subsystem, which is basically the web server, to basically then integrate with mod cluster to send out these messages. Then we add a server group called load balancer. And we add a server config called load balancer, which is the name of the server. And then we start this server in this load balancer server. So we see this load balancer server starting. Now we need to wait a bit for the backend servers to register themselves with the load balancer. So now both backend 1 and backend 2 are registered. So now if you go to port 8080, this is the load balancer. So now this has forwarded the request onto the backend 2 server. And if you refresh, it's now routing this request to backend 1. So it's doing round robin because at the moment there are no sticky sessions or any sessions running. So just round robins. And then now if we initiate a session, so now we're using backend 1, and all the subsequent requests also get routed to backend 1. However, now if I take down this node, backend 1, and and do refresh, then this request should now fail over to backend 2, and the request count should be 10, and it works. So then the other major enhancement in Undertow for WildFly 9 is that we now support HTTP2. So a quick history of HTTP 1.1, which is the current version, is that it's been around since 1999. And it's worked well, but over the last few years, the demands of web clients have become more and more demanding. So the main problem is that it's resource intensive. That one connection can only handle one request response at one time. And if you have lots of stuff on your web page, you'll need lots of connections to get everything down in order to reduce page load time. It's also verbose. So the headers are human readable, and they're sent backwards and forward with every request, uncompressed. And this also means you have a lot of duplicate data being sent back and forth as well. So the goals of HTTP2 are to basically reduce the page load time and to have a more efficient protocol than HTTP 1.1. So it's binary, and it can multiplex requests and responses. So one connection can handle several requests and responses going back and forward with some IDE stuff happening, so it can do several things, or handle several requests. It compresses the headers, both using some kind of Huffman encoding and with dynamic lookup tables, so an ID becomes a lookup to the actual header value, and the server and the client negotiate this early in the first requests that go over this connection. It also allows server push. So, for example, the web server can basically anticipate what data you might need once you've made a request. So the first time somebody goes to your website, they'll probably need to download lots of JavaScript and CSS and images and stuff like this. So it will basically allow us to anticipate this and to eagerly push this down without having to make all the requests from the client. So the good news is that there's not really any need to change anything in your websites to use this. You just need to set up the server to support HTTP2. So HTTP2 basically runs on the same port as the standard web server. And the way it works is you make a HTTP 1.1 request with a request to upgrade to HTTP2 if the server supports this. If the server doesn't support this, then we just keep on using HTTP 1.1. But if the server does support it, then we switch to using the HTTP2 protocol. And similarly for when using TLS, so although the spec doesn't require TLS to be used, most browsers who support HTTP2 actually say this can only happen over an HTTPS connection. So at least Chrome does this. So the stuff that the browsers and the server use to negotiate HTTP2 over HTTPS is something called the application layer protocol negotiation. And this, unfortunately, is not part of Java 8 yet. So out of the box, you can't really use HTTP2. But it's coming up in Java 9. And once it's in Java 9, it will probably be backported to whatever version of Java or whatever update of Java 8 is the current one. So this blog here basically shows how to set up ALPN anyway using a third-party implementation. And I'll show you in the next demo as well how to do this. Okay, so right, so I'm actually copying it across locally, but what this script really did was to basically download some test certificates, to download the ALPN jar, and to set this in the boot class path in the standalone conf, so that this jar is then available for the JDK to use. Then it starts WildFly and configures it with a key store containing the certificates that we downloaded to use with SSL, and references it from the HTTPS connector. So now if I run this script, then I need to set it to JBoss home. It'll wait a few seconds before trying to update everything. So now that should be done. So now if I start the server normally, okay, so now if I go into the developer tools, and I've accessed it by HTTPS, then in the request headers, we see these type of headers here, which are basically HTTP2 style headers. So that's kind of the proof that HTTP2 is enabled. Actually, I had some Chrome plugin. Oh, there it is. That blue arrow as well means that HTTP2 works. So now the server management improvements that we've introduced are suspend and resume and graceful shutdown, which basically means that you can suspend the server and requests that are already being processed will complete, while it will deny any new requests to come in. The offline CLI, which allows you to embed a server process within the CLI process to configure the server as an alternative to doing it remotely over a socket or editing the XML. We also have the ability to download log files via the management API, which might not be that exciting, but still it's there. It's useful for the console to be able to do this. And we're able to extend the host controller process by installing subsystems on it. So first of all, we have the suspend resume. So like I said, once you put the server in suspend state, it rejects any new requests while allowing the things which are already being processed to complete before actually shutting it down. So we have some new CLI commands to basically suspend and resume the server, or to shut down with a timeout for the requests to complete. So to show the suspend resume, I'm going to use a servlet. So to make it a bit more interesting than just a servlet with a sleep, I'm doing an asynchronous servlet with a sleep. So that's using a new feature in Java EE7, which is injected executors, so the Java EE7 concurrency utilities. So it's an asynchronous servlet. It reads a sleep parameter to get the timeout, starts an asynchronous request, and then the runnable implementing the job basically just prints, does a sleep and prints out that we slept and for how long. Now deployed this, and it's deployed. Then now, so I'm just executing some requests. So I'm not going to execute the suspend call quite yet, just getting ready. So now I'll execute one, which will take 15 seconds to complete. So this should occur here. Now I'll suspend the server. It doesn't allow any new requests, but hopefully in a few seconds this request, which is in flight, should complete. Yep, so that worked. Then we can resume it again. And we're back to processing requests. Then the next server management enhancement is the offline CLI. So this basically makes it possible to configure a server without running the server and connecting the CLI via socket. So all the usage of the CLI we've used so far basically uses this mechanism. The other alternative to configure a server until now has to be to go in and edit XML. So the offline CLI allows a third mechanism, which is basically booting up the server from within the CLI process. It boots it up in admin-only mode, which means that it doesn't open any sockets or install any runtime services. All the work that we do via the CLI on this underlying server process is to basically change the configuration. So you might ask, why can't I just go and change the XML if that's what I want to do? But in some cases, if you want to reconfigure, for example, your SSL setup on a server, it's easier in some cases to just have the commands in the CLI in a script to update those without touching everything else within the XML. Because if you have 100 servers, they might have similar SSL setup, but other stuff might be different. So it's an easier way to basically update a few things. Currently, this is only supported for the standalone mode, but we're working on supporting this for the domain mode as well. So now if I read the values that are set up for the management interface, which is the interface that the CLI connects to the server over, its INET address is basically the address it's bound to. So we don't have a value for the system properties. It's basically bound to localhost. So now I can So now just change it to get rid of that system property, and we need to reload the server. So in this case, it's fine because it's an existing IP address. Oh, oops. So we change the value. Now I can actually break the whole setup by changing this address to something which doesn't exist on my machine. So we now need to reload it again, and we should see some problems in the log. So now we can't actually do anything with traditional CLI to recover from this anymore. We could go and change the XML, but instead I'll start the embedded CLI. So now it starts a running version of JBoss, this lightweight version without any runtime services installed. Under the hood, I can see that the value is this bad one. Change it back to something which works, and then stop the embedded server. And now we should start fine again. Okay, another new feature is now that we support downloading the log files via the CLI. So you can basically go in to the logging subsystem. So this is a new command, read log file. You can specify which bits of the file you are interested in. And you get them in the CLI. There's also a new attribute which is not so useful for the CLI. It gives you an index into stream attachments, which is a new feature in the management API as well. So you can actually have streams attached, but from the CLI, it's not really that useful. It's however used in our HTTP management API, which I won't show you, but this is how the console then downloads the log files, so you can view them from the management console. And here we have a little thing which executes the same command that I tried to do in the CLI, giving us the strange stream index back. So it builds up the operation using our Java API, executes the command, checks that the result was okay, gets this stream ID in the result, and then uses the stream. So this is a good way to transfer lots of data between the server and the client. So you don't have to put everything in the memory, like the CLI command, which had the embedded log file in the return value. So, so it basically just connects to the server and prints out the log. Then the final server management enhancement is that in WildFly 8, the only way to extend the host controller is basically if somebody at WildFly does it for you. There's no pluggable functionality on the host controller. So in the domain XML, we have the notion of subsystems. So an extension has the definitions for the subsystems, and then you define your subsystems. And this is just templates for what will be run on the servers that belong to this profile, but they do not affect anything on the host controller at all. So the new feature in WildFly 9 is to be able to define these subsystems in the host controller. So it has a new extension section and then a profile where you can define subsystems. So that doesn't really mean that you can go crazy and start adding EJBs and Undertow and stuff like this to the host controller. the subsystem author needs to have made this capable of being run on the host controller. So unless this registration set host capable call is made, then the subsystem won't work. And this is because you need to do some sort of tweaks internally to have it workable on both the server and the host controller. But if you are kind of a power user of WildFly and comfortable with implementing subsystems, then this is a good way to extend the actual host controller as well. Then the final topic is that we've now split the code base of WildFly. So before, the whole thing was in one Git repository, so that had both the core management functionality and all the EE and clustering stuff. So the core has now been pulled out to its own Git repository, and this contains basically like the heart of WildFly. So it contains the concurrent service container, which wires together all the services that make up the server. It contains the management layer, which is basically the infrastructure for all the stuff that I've been doing with the CLI, and it gives you domain mode. It contains the core deployment framework. So, for example, the E2B subsystem will install some deployers to read all the E2B annotations and install the EJBs. And of course, it contains the modular class loading. So it's basically like just a stripped down core containing the management infrastructure and logging, and that's it. And also the request controller, which allows the graceful shutdown and suspend resume. So this is important for a few reasons. So one is that we have other products at JBoss who want to sort of build on top of WildFly, but they don't need all the EE stuff and clustering and so on. So it's kind of like a stripped down core for them to build on top of. And some users also want to be able to remove a lot of the things in WildFly as well. And another important part is that we want to move forward to a state where we get actually sort of really composable servers. We say, for example, I want EJB. So, okay, I'll put in EJB, but then obviously transaction security and a few other things. If I also want web, then I need Undertow and a few other things. So it'll figure out all the dependencies eventually. So we're not quite there yet. But what we have is we have a new web distribution, which is basically the core package that I mentioned, along with Undertow, the web server, security, and naming. And then the full distribution, which contains all the subsystems, which gives you the full Java EE stack or Java EE7 stack and clustering. And all these distributions are created using our tooling. So central to this tooling are two concepts. One is a feature pack. So basically, a feature pack is sort of a mixture of both modules, which are the jars that your feature needs, or the ones implementing your feature. The configuration, which is basically subsystem snippets, which go into the domain controller profile section of the standalone XML configuration. And content files, which are things like properties files, scripts, and so on. So a feature pack's defined using some XML format and references the Maven artifacts from the repository. And it's built using a Maven plugin and deployed as a zip as a Maven artifact in the Maven repository. Then the provisioning part takes these feature packs and creates the server. And this is also, again, usable either via standalone mode or as a Maven plugin. So we basically only have 3 feature packs at the moment. We have core, the web, and the full distribution. But the plan ahead is to have a fully composable app server using So you can decide exactly what you want in your WildFly provisioned server. So I'm going to skip that demo. Right, so then what's coming up in 10, which is the next release of WildFly. So we are consolidating the messaging implementation. So the messaging implementation we've used so far has been Hornet Q, which has really, really good performance. But ActiveMQ is sort of more popular and apparently easier to configure. So there's a new ActiveMQ project called ActiveMQ Artemis, which will be in WildFly 10. And this is a merge between Hornet Q and ActiveMQ, taking the best parts of both and making it even better than either implementation was, server or messaging implementation. The other thing is that we're revising the security infrastructure. So the security frameworks that we have internally in WildFly 8 and previous are quite old. They kind of start built on stuff that was there in JBoss 4, if not even earlier. And there's just an evolution of this. And there's a limitation to how far you can push this, and you're not really able to support all the latest security standards with this old infrastructure. So we're revising this in 10, so we'll be able to support these latest security standards. We'll also be able to do things like authenticate on the client, make an E2B call to the server, and then propagate this authentication information to calls over E2B to other servers in the back end. And our SSL configuration at the moment is a bit of a mess. It's sort of scattered all over different subsystems and the core infrastructure and loads of places. So the idea is to have one central location to define key stores, which can then be referenced from other places needing to use stuff like, or to use the key stores. So this all means that we need some new subsystems to implement these. So we can't just, at the moment, the messaging subsystem is tied to Hornet Q. So we'll have a new messaging ActiveMQ subsystem. And the same for security. So we'll have some migration facilities to basically take your existing messaging configuration and to translate it into something which will work with the new messaging implementation. Then another thing coming up, which customers have asked for, is HA singleton deployments. So this basically means if you have a cluster of servers and you deploy deployment into this cluster, so there's one copy of the deployment on each server. Only one of them will actually run this deployment and be the active node. And if this node goes down, then somebody else will pick this up. So in JBoss 5, for example, we use this as the foundation for our HA JMS implementation. So all the nodes would run JMS, but only one of them would actually be the active one, and they'd share the state with persistent data and persistent queues. Okay, so that's really the end. So just to recap, we've seen that we've split the code base and we're aiming to get to a fully composable app server. We support HTTP2 and the use of WildFly as a front-end load balancer. So there's no need to have a native HTTPD implementation anymore. This can now be handled by the application server. And those two things are implemented in Undertow. We've seen the suspend resume stuff, allowing you to let in-flight transactions complete while stopping any new requests coming in. The offline CLI, which is another way to configure your application server within the same process. And the host controller is now extensible via the host controller subsystems. And all the examples are on my GitHub at this URL. And there's the WildFly project page. does somebody have some questions?
I don't know if there is any plan to remove standalone mode, because to me it's confusing, as happened to you in the demo, it's confusing to have two ways.
No, we'll definitely keep standalone mode, because this is what, at least in development mode, you'd probably use standalone mode. If you want to manage lots of servers, you'd probably use domain mode. But under the hood, the resulting servers are the same thing, really.
Do you have any sort of expected date for the sort of, I know you said the line's coming out, you reckon confinement sort of 3 weeks after that. Is there any sort of scope for when 10 is going to sort of
10, there was a mail about this on the WildFly Dev web's mailing list a few days ago, but sometime in autumn, I think. I don't remember the exact date. But we're kind of really aiming for rapid releases now. We had sort of a big break between AS7 and WildFly 8. But now that we are free to kind of release quickly, we're aiming to do this. Any more? Okay, thanks.